crazy new model that combines diffusion and autoregressive transformers. So image generation and editing with diffusion, and next token generation with autoregressive LLM. And it's using the autoregressive language token generator, text generator to plan, and then using that plan to generate image with the diffusion. First, the large language model takes the user's prompt and image if user wants to edit the image, or just the prompt to generate an image. And instead of generating text words, it generates a sequence of discrete image tokens, so just image tokens. It's like a blueprint for the final image, or a plan. So this plan contains what should be on the image, like user instructions, high-level semantics, composition, etc. And then there is a cross-attention between the generated image tokens, the plan, and the noise when the diffusion transformer. So it's a diffusion transformer that pays cross-attention. So this plan will help it denoise or generate image according to this plan, according to maybe autoregressive model has some strengths, so it can put its own strengths into this plan. And then it augments diffusion transformer to make the better image at the end. Autoregressive models are good at reasoning, following complex instructions, and understanding the relationship between objects, compositionality. And diffusion models are good at creating visually stunning, realistic, and detailed images. So diffusion models are good for like vision, for looking good, and autoregressive models are good for reasoning and thinking. So basically, this diffusion transformer will make this plan look good. So this model aims to combine best of both worlds. And so the autoregressive model will just generate these visual plan tokens, and they might say what objects are in the image, where they are located, their rough shapes and colors, and overall composition and style. So it's like an abstract representation explanation, and then diffusion will materialize this into an actual image. So the autoregressive strength is understanding the user's prompt, the text, and possibly image tokens if there are image tokens if user wants to edit the image, and then translating that into the plan. So as I said, autoregressive models are good at this thinking and reasoning and planning. And here, autoregressive model can just take a prompt, a red cake and a purple chair, and so this generates plan, which then converts the plan into, it can convert into multiple images, but I will show this part of training later. But we will go a bit back. So autoregressive models is still selecting over possible plan tokens. So it has a limited amount of plan tokens that it learned during training. It learned what each token should look like. But, autoregressive models, they need to select transformer. They need to select from a limited amount of tokens. They cannot select or create new tokens from infinite distribution, which actually diffusion model does. Diffusion creates new images from almost infinite distribution of all possible pixels. So we would, for example, have 8,192 unique vectors, plan vectors, that autoregressive model can choose from. And this is, I believe this is power of 2, and it should be power of 2 for better, faster computations on computers, on GPUs. So think of these visual tokens, or I should say even plan tokens, as building blocks for images. They're not like, one token is not necessarily an eye or an arm or an ear. It's like a building block that is a lot more abstract, that can have some shapes, patterns, colors. So then if you combine two of them, it's gonna have the concept of a green eye. For example, it can have some patterns of like circles and green color, and that resembles an eye. This is because we want the autoregressive model to have these building blocks, Lego blocks, to create any plan for any image. So these tokens, these plan tokens or visual tokens, they are visual plan tokens. They can represent some shadows, some corners, some spikes, some wooden textures, iron textures, reflective material. They can combine multiple of those in a single visual token. So maybe this first token describes some spikes and metallic reflections, and then this token describes some fur and some maybe green color, and smoothness. So it's gonna combine a lot of these tokens. It's gonna give it to the diffusion transformer that will convert them to this nice looking image that combines all of these concepts. But imagine that these tokens also like describe the text. So it will understand the text the user prompts just by looking at these tokens. And so these tokens are learned during the training. So when we train autoregressive model, we edit these tokens, and later when we are finished learning, we just use them later. So later we just see text, image, generate the tokens, and then use. But during the training, they're changed. So we just train them on millions of images to generate, so we can generate good tokens that will end up generating good images. That's how they are trained. And so that those images correspond to text and image tokens. And the diffusion transformer is the artist that will convert this plan into a nice looking photorealistic maybe, or cartoon or some image. There are multiple insights they gain, so architecture isn't everything. This is connected to the bitter lesson where you just need to scale, add more training data, add more images, and often simple architectures with a lot of compute and training data outperform complex architectures. Because complex architectures are harder to stabilize, you can make more errors there and more mistakes, and then training can collapse. We can also implement reinforcement learning where it generates a few images and then we pick the best ones or correct ones, because this is a purple chair, these are blue chairs, and train the model with reinforcement learning as well. And this can benefit from already existing reinforcement learning infrastructure for the language models, because that same infrastructure can be applied to this autoregressive transformer that generates a next visual tokens. And during the reinforcement learning phase, they only update the autoregressive model and they use a GRPO by DeepSeek. It's just a technical strategy. Check out my video on PPO LLM reasoning so you will learn a lot about fundamentals of reinforcement learning for LLM autoregressive transformers. Reinforcement learning is only used on the autoregressive model and diffusion transformer remains completely frozen. So a diffusion transformer is just updated initially with the pre-training and instruction tuning phases, but not with reinforcement learning. As I imagine, this is because it's difficult, or maybe there is no way to do it with reinforcement learning, or there is no good way to do it. And you will still have two moving parts, which can cause a lot of issues and unforeseen problems. So just freeze the diffusion transformer and update autoregressive one with the reinforcement learning. That will be it for this video. Join my school to become AI researcher, because all of these courses is free for now, but it's gonna get paid. So get a lifetime access right now, link below the video.